So again, this is the beginning of the third session of Intro to Python. If you are just joining us this time, there's an entire walkthrough and guide. I sent it with the emails, and it's on my website, profammons.com, Intro to Python. And it has everything you need, even the registration link. If you know anybody who wants to register, here's a registration link. Systemic also lists the registration. But more importantly, you have here getting started with PowerPoint slides. Just follow the instructions to catch up, making an account on Replit, and then creating a new REPL, etc. And then we're ready to go. Here's the tutorial I reference, W3 Schools, really great resource for HTML, CSS, JavaScript, Python, SQL, even C++. They even have a C++ tutorial. And believe it or not, I actually use it as a reference for my students in my C++ class. And then there's also the posted videos, recordings from sessions 1 and 2, along with the starter code that you'll need to follow along with those. And today, as you can see, there's no video posted because we're currently recording. This will be on looping, so repeating code. So we'll be talking about while loops, and maybe if we have enough time, a little bit about for loops, which is just a variation on a loop. All right. So hopefully everybody's good with that. Let me put a link in the chat just to make sure that we'll be making an RPG. Oh boy. We got a post here. Got a pretty long program. Hey, so it's like some good work though. Very nice. Keep up the good work. So what we're going to do today, we'll get started, and a bit of review, not much. I don't want to spend too much time on that, but you'll want to go ahead and create a new REPL and Replit as the slide indicates. Then you'll have an environment set up to start working. It should be Python version 3, something, 3.8 probably. Once you get that up, if you haven't already, here, and these slides again, or at least the content that's on these slides is all available on profammons.com, the site I referenced and put a link to. So this is how you would print to the terminal. This is how you get input from the user, text input, right? And I have some screenshots of the examples. This would save input to a variable called name, and then we would print the contents of that name variable. So that's all I'm going to do for review of input output. Variables, quack quack. So Python again is duck typed. So if it looks like a duck and it quacks like a duck, it's a duck. In other words, if it looks like an integer or a whole number, it will interpret it as such. If it's a string, which is just a bunch of characters strung together, then it will see that variable as a string. Data types are extremely important, and they underlie all programming languages and computing systems. However, in Python, the language tries to do a lot of work for you, which is a good and a bad thing. It's a double-edged sword. It makes programming easier because you can do things like y equals 1, 0, and it will automatically know that y is an integer and treat it as such, so you can add and subtract and multiply. And then if you put it in quotes, it will not treat it as a number. It'll treat it as a string. So the string 1, character 1, the character 0. So you couldn't just add that out to 1 and get 1. You would actually be gluing strings together, which is called concatenation. The point is, it takes care of this for you, but that overhead has a cost, and it makes the programs run a lot more slowly, and takes up a lot more CPU and memory. To write the same program in something like C or C++ is more difficult because you have to declare or tell the language what data type you want to use before you can use it. That makes it harder for the programmer, but easier for the computer, and thus the computer runs the compiled program more quickly. Any questions on input-output variables before I keep moving on? Just want to spend maybe 5-10 minutes max going over this stuff just to make sure everybody's still on the same page. No worries, it happens with the chat. All right. So the last thing we covered and the last program we made together involved branching, which is the useful feature of a computer, which involves making decisions. Again, a computer is not particularly useful to us if it can't make decisions based on varying input. In this case, we're using Python's if, elif, else, which is really if, else if, else if, else if, else if. We talked about this last time. You can have as many of those elifs as you want in between the if and the else. And if any of those are true, the first one that is true gets executed, or what is inside of it, which is indented over, gets let me use a pointer for that. Is there a pointer? Annotate. So anything that's in here, this gets executed if this is true. If that's false, but this is true, this gets executed. And if neither of those are true, then whatever is indented underneath this else gets executed. So if dragon is friendly is true, it prints this out, else if, or elif, right? Some languages have else if, most of them do actually. This is a very Python-esque thing. Elif, they try to get rid of as much as possible. So that's short for else if. Dragon is asleep. These are both Boolean variables that have true or false in them. And if that is true, then it would print this out, assuming this is false, because it would never get to this if this first one is true. Let me clear the annotation. However, if both of these are false, dragon is friendly, dragon is asleep is false, it prints whatever is in else, because this happens, unless either of these is true. And here's a flowchart showing this. So you have start the program, show an introduction, player chooses a cave, and then here's our if, really. This is the part that's actually in the code. If the dragon is friendly, true, player wins, right? So dragon friendly win. If false, then it goes to another if, which in other languages you actually just have nested or inside of each other. If, else, if, else, if, else. This is a shortened version of that to make it easier to put everything in line with it to the left. So it's a kind of a shortcut. You'll see that if you look at something like C++ or C. Is the dragon asleep? Then it asks that. If that's false, only if it's false, right? Because remember, if it's true up here, it skips down and just leaves. If it's true, player wins, dragon asleep win. If it's false, player loses, right? So both of these have to be false for you to get to the else and get to the end. Any questions on the basics of branching statements? All right, excellent. So here's a little bit of comic relief for today, and this is about loops. So the programmer got stuck in the shower because the instructions on the shampoo bottle said lather, rinse, repeat. Well, if you repeat, that's lather, rinse, repeat. So do it again, lather, rinse, repeat. And so yeah, it never gets out of the shower. It's pretty corny. It's the best one I could find. I went through a lot of different versions of these loop jokes. Tried to make my own too. It was it's harder than you think. Unless somebody has one for me, I'm always all ears for good entertainment to keep people awake, especially in programming, because sometimes it can be a little boring for people, or at least feel like a grind. But hopefully this is fun-ish. Okay, so we have a problem. Our problem is we want to play Duck, Duck, Goose. Everybody know what Duck, Duck, Goose is? The game, the children's game of running around in a circle, or walking around the circle of children. There's a picture from Wikipedia over here. And the goose goes around, the it person walks around and taps the heads of everyone going around, not good in our current situation, but the pre-pandemic times. So it goes around, taps each person's head. Eventually, instead of saying duck, the person says goose, and that person is now and has to get up and chase that person around the circle to get back to the place that was taken by the person chosen before the person that was tapped as goose catches them or tags them. And that's how you win or lose. So the person, if they make it to the space and time before getting tagged, that other person becomes the goose. Otherwise, that other person that originally tapped, right, the it stays it. So we want to have a program that, now we're not going to implement the entire Duck Duck Goose game. That's kind of complicated, especially for less than an hour of a seminar. But what we are going to do is have something like the script of the game, so that it prints out sort of what the person is thinking. So it's going to ask the first chosen person to walk around the circle, how many ducks do we want to call out, before we say goose? And so that person will input this information, and just as with the variables we went over and talked about, I have a variable here called ducks. And ducks will be set to whatever number the person puts in, the user. Excuse me, I keep doing that. And that will be converted. Remember, when you're inputting in Python, you're just putting in strings, characters. So 1 or 2 or 3 is not actually the number 1, 2, or 3. It is the visual character 1, 2, or 3. To make it a number, we have to actually convert it to an integer. We convert it to different things, but here it's just simple. We'll just convert it to an integer. And that's what this int is for, wrapped around, right? We pass in to the function int, which converts something to int, the output of the input, the return value, or whatever the user typed in. This gets replaced with it. So for instance, say the user typed in 1, it would actually come out as this 1 as a string. And then the int 1 would turn it into a numeric 1. So that's visually what happens, right? What I just did. If you want to think about how it's breaking this down. If you've done math, right, you have order of operations. You do the thing inside the parentheses first. So we do the innermost thing here. We get the string, which, it's not really math, I guess, but it's a kind of math. It's computer science, which is applied math. We convert that to the string, right? It gives us a string. Say the person put in 2 this time. And then it takes that string 2, converts it to an integer 2, and then it sets that value 2 equal to the symbol variable called ducks. And then we have our nice our integer here that we need, because we're gonna have some questions to ask. We want to repeat duck, right? Any number of times. So believe it or not, this was my first solution. I was a self-taught programmer, confession. And then back in the day when the web was very much in its infancy, and it was extremely expensive to go online, and almost impossible to get any kind of real help with programming in any meaningful form. Things have come a long way since then. Back in my day, right? So long story short is, when I first thought of the idea of I want some code to run more than one time. And I want to be able to tell the program I want it to run 2 times or 3 times or 10 or 100 times. Well, I didn't have the concept of a loop. I didn't know that you had a loop. I literally learned, by the way, from a alphabetical language book. Just had the commands and the syntax of the language. It was not like a how-to program. Probably not the best way to learn, but definitely ended up, copy and paste, sort of, yes. And this is what I did. I knew how to make conditional statements, right? So I said, hey, if ducks equals 1, remember it's double equals. If you're asking whether or not it's equals, single equals is assignment. So that means I want to make it equal to, right? But double equals is asking the question, is it equal to, is equal. Okay, so I ask if ducks is equal to 1, then print duck. Else if, or elif, ducks is equal to 2, so say it's not 1, so we go to the next one, and it's 2, then I print duck, and then print duck again. You can probably see where this is going, maybe. So elif ducks equals 3, so that means is ducks 3, then I print duck, print duck, print duck. Okay, well, if I wanted this to be, to have at least the capability to print up to 20, this is going to be a really long program and a lot of repeated code. Well, luckily for us, and lucky for the younger me, I finally figured out that there is a way to do this and to have the computer do something very useful, which a computer is great at, is to use a loop. All right, and the loop, its function is to repeat code. So here we're sort of repeating it, but we're doing the computer's work manually, which is not what you want to do. You want to make the computer do the work. That's what it's for. So let's go over to let's see, ripple it. I'm gonna put this up. Oh, and I need to change screen size. Sorry, guys, I forgot to do that before I started. I was trying to bring everybody in. Let's see. Let's go to 175. That should be good. Nice and large, easy to read. So back and ripple it. There we go. All right. Is that readable? Is everybody able to read this more or less? Excellent. I'm getting some positive answers here, so I'm gonna take that as a positive. All right. So I've actually done some extra stuff here that you don't need to worry about. I can talk about it. I might talk, we probably have a little time to talk about it. I've just made a little function here, and you make a function using def as in define. This is short for define. The function called delay. And what I've just done is I've used this special library that I've imported called time, and it has a function in it called sleep, and I make it sleep 1 second, which means it just pauses for 1 second. That's all it does. It just delays for 1 second. So I'm going to minimize that so it's not really in the way. But this is our Duck Duck Goose game, right? These are comments. Remember how we talked about comments? Hashtag. This is for humans after the hashtag. That's why it's all gray as well, because the Python language just doesn't pay any attention to it. It just skips over it. So we can put nice notes there. And there's the Wikipedia reference to the game. So here I have the beginning of what I showed on the slide. We have ducks equals int wrapping how many, and I was able to put the full question here, whereas the slide was a little more limiting for space. So input how many ducks to count before saying goose, which is more of what we're doing here. And then it takes that, converts it to the integer, just like we talked about on the slide, then sets that equal to, or assigns that value to the variable ducks. And here I have if ducks equals 1, print duck, and then delay, right? Because if I just print it out, it's going to almost instantaneously do it. It's not very useful to sort of basically emulate the game, right? Because you wouldn't say da 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 da. I mean, and you couldn't even say it nearly as fast as a computer can do it. That would just be pointless. So have a delay there. Now we want to do our elif. I'm just going to do it the quote unquote dumb way, the way I did it, my dumb early self did it. Just ignorant, maybe not dumb. Ignorant's a better word, right? That's what we need education for. Somebody to show you the way, show you how to do something the most efficient way, or a more efficient way at least. But we'll do it this way for now. So print duck delay, because I don't want it to just print duck 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 duck. It's very, very fast. So I'll print duck again. This is twice. And then I'll have one more delay. And now I'm going to start doing the copy paste thing, which yes, I did that as well. I'm going to do an elif, and we're just going to do to 3, right, before we finish this, because hopefully you can see where this is going and why it's not a great idea. Again, make sure your indentations are proper here. All right, it'll give you an error if you don't, right? Because that's not expected. This needs to be under or running inside of this block, right? And it's under elif, so it needs to be indented with it. And then I need one more, so let's go one more, just like that, and then make the indentations match. Okay, so now let's run it and see what happens. So run. This should be fairly straightforward, right? From the last episode. How many ducks to count before saying goose? Well, let's say 2. So I say 2, hit enter, and it says duck. Waits a second, duck, and waits a second, goose. There you go. So not a complicated program, but it's going to get really messy if we have to go up to say 20. Right? That's not feasible. For such a simple program, you wouldn't expect to have to write literally, 100-ish. Yeah, it'd be about a little over 100 lines of code. That's crazy, right? Especially for Python. You might expect to write 100 lines if it were in something called assembly, which is one step up from machine language. And if you have questions about that or want to learn more about that interesting stuff, send me an email. So how do we get around this? Well, again, we're going to use a loop. So let's go back to the slides and go to our last slide before we get to, do more fun programming. So the first loop we're going to talk about, and by the way, all loops are essentially the exact same thing underneath the hood. Okay, so in terms of how it works, we'll walk through it. So here, let's look at the flowchart first, the graphical, right, version over here to the right, before we even talk about, any code. So this is our program, but now we're going to use something that's going to allow us to not type over and over print duck, and et cetera, et cetera. We're going to be able to just write it. Literally, print duck only appears one time in this new version of the program. Yeah, flowcharts. Yeah, not the most fun to make, but they're useful, right? Because it gives you a visualization, especially if you're not familiar with the code or a particular language. It does make it easier to understand the flow of the program, hence the name flowchart, because it's flowing, right? So first of all, you start the program. We ask how many ducks. And then we have this interesting thing called a counter. We just made up a variable and we call it count. You could call it I or X or whatever. I just called it count here because we're going to count with it. And I want to start at 0. A for loop would be appropriate here, but I'm starting with the most basic loop, right? The most generic loop, which is a while loop. A for loop is a specialized version of a while loop. And we'll talk. Like I said, I haven't got that slide on that, but I will show that probably towards the end. So, because in essence, this while is really just an if. If you want to think about what the computer is actually doing, it's actually doing this. It's actually saying if and a condition, and it's saying if. In this case, now I'm going to link it with the code. So if, you can think of the while as like an if statement because it's a condition. It says count less than ducks. It's asking the question, is count less than ducks? So count is a variable. It has a value. It starts off at 0. Duck starts off at, whatever we put in. Let's, for instance, say we put in 2, right? So we're going to have 2 here. So let me say ducks. I'm going to put this over to the side. Ducks. Our little variable monitor equals 2. So ducks, and we make that lowercase so it matches. So ducks equals 2 at this point in the program. So if I ask you the question, is count less than ducks? Is 0, which is the value of count, less than the value of ducks 2? Is 0 less than 2? Is that true or false? 0 less than 2. What do you guys think? Not all at once. Right, it's true. 0 is, in the number systems I'm familiar with, 0 is less than 2. So it's true. So if it is true, which remember, like I said, really what's happening under the hood is just an if statement. You can, the while is kind of a pretty syntax way of saying we have a loop here. And it also adds something I'll talk about in just a second. You have true, and then it goes to whatever's inside the loop. In this case, we have print duck. So it prints duck to the screen, right? Then we need to do something. We need to say, okay, now we've printed duck one time, so I want to use this counter. So there's a reason I had this counter variable. I need something to hold the current number of times I've gone through this loop, right? That's what I want, because I want to know when I'm no longer count less than ducks. I want to know when this is no longer true, right? So, so if I go through this one time, I add one to count. Count then becomes, at this point, what? Let's see, count. So I put count, and I add 1 to 0, and it becomes 1. So now count is 1, okay? So let's go back up here. Ducks doesn't change. Duck stays the same, right? There's no assignment statement for ducks except for it's in here, right? I've implied it here and it's in the code. So we ask the question again. That, by the way, this is a jump statement, a go to. You may have heard of go to or jump. And if you have, you probably heard someone say, that's a horrible idea. You should never, ever do that. And they're right. You shouldn't. But ultimately, what happens is this gets translated into what's called a jump statement. And it basically says, jump back to this line of code. So it will get here to the end of the loop block, and it will jump back to the top, which is this while line. Okay, and then it asks the question again. It says, now is count less than ducks? Well, count is 1, ducks is 2, 1 is less than 2. That's true, right? I know this is really, I'm really making this super simple, but I'm trying to let you focus on the logic of the program and not have to think about numbers very much. So I'm using 0, 1, and 2. So count less than ducks, you have 1 less than 2. That's true, right? Because 1 is less than 2. So true. So we don't go this route, which would be another jump, and it would jump outside of the loop. It would jump to the next line outside of the loop. We don't do that. We continue on. We print duck again, which is what we want, right? Because we've only printed 1 duck, and the user asked to print 2 ducks. So duck gets printed again, and then we go to this line, it adds another 1 to count. That's called increment. Increment. The opposite of that is decrement. So increment is to add 1 to something. Decrement is to subtract 1 from something. So you can see we could count up or count down, right? We're counting up. Could have counted down, could have started with 2 and gone to 0. We're going to 0 to 2. That's more natural for most humans anyway. So add 1 to count. Now count is 2. So count is 2. Now there's this invisible jump statement that happens in the actual machine code that this gets interpreted, converted to, right, by Python. And then it jumps back up here and it asks the question if. Remember, there's just a while here, but it's technically just an if. It's a comparison. So it says, is 2 less than 2? Is that true or false? 2 less than 2. What do you guys think? It's false. 2 is not less than 2. 2 is equal to 2. Anything less than 2 would have to be, 1.9999999. If we're talking integers, the next integer that is less than 2 would be 1. There's nothing in between 1 and 2 for an integer, all right, because it's not a decimal number. It's not a real, it is a subset of the real number set, but we'll leave that aside. So at this point, it's false. And we've done what we wanted. We printed duck 2 times. So we hit the false. And that is a jump statement outside the loop to whatever the next executable instruction is. And in this case, it's just print goose. And then the program ends. That's all there is to it. That's what a loop is. So before we go further, I'm going to go back to the code, and we're gonna convert this thing into a fancy loop instead of the if statements that we've been using. All right. So instead of all of this mess, we're going to get rid of it, and we're going to replace it. So now we need count. We need to create a variable called count equals 0. So we want to set it to 0. So start count from 0. Right, I'll just put a comment there just to tell the other programmers or somebody reading my program code what I'm doing. Hopefully it'll be relatively obvious. But sometimes, what you think is obvious is not obvious even to you a week later a lot of times in your own code. So it's really good to make comments. I highly recommend them. If ducks equals 1, want to get rid of this. Now, technically, remember, it is an if statement. Remember, we talked about that. But we're going to let Python handle that under the hood for us with a new statement. So now instead of ducks equals 1, we don't really care about it equaling a particular value. We want to compare it against the count. So we want to say while. So in other words, the while, hopefully that is sort of seeped in with how I walked through the flow chart, is that as long as, or while, ducks is less than count, continue doing this block of code. Run it, line 15, line 16, we're out of the loop, jump back up and ask it again, run it again, ask it again, run it again, ask it again, run it again, ask it again, right? And whenever it's true, just keep doing that. If it's false, stop doing that and go outside of it and continue. Now, I'm going to intentionally just leave it there and run it. Anybody guess what's going to happen if I run it like this? And I put in, say, 1, 2, or 3. Well, let's run it and see. That's the beauty of, see, my undergrad was in chemistry, and I have to tell you, man, that was, I enjoy this a lot more, and a lot of that has to do with the fact of the instant gratification. So if I want to run an experiment with a program, all I have to do is change a few lines or even characters and run it again. Whereas with the chemistry, yeah, that was a lot more difficult. I had to literally wash glassware like 3 or 4 times, get out new reagents, properly dispose of things. It was just a whole deal to do something over if you messed up any at all. So this is a lot more gratifying and rewarding. At least I hope for you guys as well. So let's run it. So let's go run. And so how many ducks do you want to count before saying goose? So let's say 3. Okay. Oh, I think I messed something up here, didn't I? Yep, I messed up my condition. So my condition was count less than ducks, not ducks less than count. See how easy it is to mix up these things? See, it happens. It happens. Even if I have the co-host here watching the chat, it happens. I mean, I could have just changed the direction of the sign, but it makes more sense to put it in this direction. So while count less than ducks. Now, it went straight to goose there. Why is that? Because 3 is not less than, was not less than 0, because ducks was, I was saying ducks less than count. So I fixed it now. Let's run it again. And now the intended error now, 3, duck, duck, duck. Oh, nope, before 5. Oh, uh-oh, we have a problem. Houston, we have a problem. So what's going on here? I think somebody in the chat said it, because there is no counter that goes up. So we have a counter, sort of. I mean, we have a variable to hold the value of the counter, but we never change it. By the way, to get out of this, you can either hit Control-C or stop at the top. That's called an infinite loop. And the first time I got into loops, and even past the first time, few times, I guess, it happened, right? Is you accidentally put a condition in that is never false. In this case, right? Sometimes you have a condition that when it's true, it jumps out, but in this case, it's when it's false, it stops looping. And that's because we're not changing count. Count remains 0. So if ducks remains 3, which we put in, and count remains 0, this will always be true. Right? Because 0 is less than 3. So it'll continue to execute forever. Because the computer doesn't care. It's not a sentient being or a biological one that needs food, drink, water, sleep. It'll just keep going as long as there's electricity and the code tells it to, right? And there's no physical breakdown of the electronic equipment. So we need to add a line of code, and I have it here, right? You saw it, and I talked about it in the flowchart. We need to increment the counter, so we need to add 1 to it. We don't want to say count equals 1, right, or equals 2, because we don't know what count is at any given time we're looping through this, right? We want to say count equals, we want to set it equal to whatever it currently is, so itself, plus 1. So if count is 0, plus 1, 0 plus 1 is 1, and then it sets it to 1. Order of operations is right to left, by the way. So that's why this works. right? So it gets the current value, which is 0 in the beginning, adds 1, and then sets count to 1. And it goes to loop around the next time if count is still less than ducks, that is. Then counts 1. And so if count is 1, just like we saw over here with our flowchart, it says 1 plus 1, and then it takes that 2 result and it puts it into the variable count, right? And then it goes back up to while, and et cetera, et cetera. Is this clear as mud, or have I beat the horse in the ground 10, 20, 30, 60 feet yet? Hopefully I have. To stop the ducking problem, Control C. So press Control C or the stop button at the top. The same one as run. So if you run it, so I'll run it again. Let's see, run. There we go. Say 2, and then duck. You can hit stop. It'll stop it. So either way, controls. If you're in a terminal, if you're using Python not through Replit but on your own machine, you've installed it, which I would, if you want to really get serious into this, you would want to install it and run it locally. Then you would need to do something like Control C, which is the sort of general for Windows and Linux systems, and even it's Command C for Mac. No, I actually think it's Control C in the terminal. The control, there's another control key, and that is terminate the process. It tells the operating system to terminate the process. By the way, this is a virtual machine, this whole thing over here, and it's running Linux. It's a Linux virtual machine. So if you don't know anything about Linux, you can look that up or email me about it later. So we need to add our count, right? So count, or our increment of the count, excuse me. I need to be very precise, right? Because computers are dumb. They are really dumb. So you have to tell them every little detail. So count equals count plus 1. Now I could have said plus 2 or plus 3, but it doesn't make any sense, right? Because I'm counting 1 at a time. So I want to say plus 1. There's a shortcut for this too, if you're interested in that. It's plus equals 1. This is a handy little tool, and it confuses a lot of people in the beginning. But all this is shorthand for count equals count plus 1. So it adds whatever's on the right and then sets it equal to the left. But I'll leave it in the more canonical, simple form because this makes more sense, right? If you're first seeing it, for sure. So we want to say count equals count plus 1. So now we're going to get, the count is going to go up by 1 every time. And now we should actually get out of this loop because this should become false at some point. So let's run it, see what happens. Wait a second, here we go. Put it in 3, press enter, duck, 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 goose. And then we run around the circle, right? That's all there is to it, right? While count is less than ducks, print out duck, have a delay. Again, I just did this because if I didn't watch, I'll show you what happens if I don't. It just does it really, really quickly. So I'll do say 10 this time, just to show you what happens without a delay. It just prints it out really. I mean, nobody's going to talk that quickly, right? That's so plus. So that is a good instinct, but it doesn't work in Python. I don't know why, to be honest. I don't know the rationale as to why it was not implemented as an operator Technically, it's an operator overload. When you do something like this, you're telling the system that this can do something else, right? You're defining certain operations. I mean, because technically this is an operator, the equal sign, this is an operator, and the plus equals, minus equals, times equals is the same deal, the analogs. This you can use in pretty much every other language. In JavaScript, in C and C++, in Java, so C++, C, Java, pretty much every language I can think of. So Kotlin, which is a relatively new language, Swift. There's probably only some really esoteric languages I think don't use this. So Python is kind of unusual in that respect. And you might want to look up the history of it, why they chose not to. I still haven't quite looked that up. I talk about it every once in a while, and I say I'm going to look it up, but then I don't. So anyway, it's not possible in Python. It's possible actually to make it work. You could write the operator overload and put it in, but that's a lot of work and way beyond the scope of this seminar, and even it's probably a maybe second semester in college of like Python if it were offered. Okay, so we have our nice little loop here, and our toy loop, so to speak, because it doesn't do a whole lot. Does everybody understand what we're doing? Does this make sense? Oh, let me put the delay back. By the way, a shortcut for making the hashtag, the comment, you can comment an entire line and uncomment it with Control /. It'll toggle the comment on and off. See, I'm telling you how to be a lazy developer now. Yeah, work smarter, not harder, right? So the / is the one on the question mark just to the left of the shift key. The / is the one above enter. So you want a front slash. So in a lot of languages, the two front slashes is the comment operator, like in Java, C, and C++, for instance. All right, so now let's go to another variation. So we talked about the while loop. And since we have a couple of minutes before I'm going to show you, we're going to start into, the beginning of the project that you can do over the week, the guessing game. And that's why, by the way, random is up here. I've imported a library called random because I need some random numbers. So I'll show you that in a bit. Actually, let me open that really quickly. I should have already had this open. I forgot to. Apologies. Multiplayer seminar. There it is. All right. All right. So that's open over there. Okay. Cool. Yeah, you could randomize the time. That would certainly be something you could do. But we're going to do something slightly different. And I seem to actually have lost this code. I need to go back to the history of it. I was doing a lot of stuff last night trying to make a new example. And I apparently overwrote. Always make backups. Always make backups. This is why you always make backups. So now I'm going to go to the history of it, because you can do that on REPL, by the way. You click on this little saved link, which is right at the top. If you click on that, it'll take you to the history, every little change you've made. Now here's no change. See, it'll show green line is you've added something, minus is take it away. Here I just changed, right? This is what I was doing a minute ago. So let's see. Before I go back to see, it saves every little change, which is very useful, right? This is an automated backup system, and you get this for free with Replit. Now, it doesn't save more than a couple days, so if you wait a few days, it's probably gone. But at least it gives you something to work with. Let's see. Let's restore. Where was it? It was somewhere around here. 1029. 29. Nope. 7. Well, apparently it is somewhere else. I had a Elmer Fudd and Bugs Bunny game, which I'm gonna have to find and get to you after this. That was the demo. It was a random thing. We'll do it with random numbers. We'll just make one up here. Sorry about that. So we'll just continue. I want to show you about for loops. So let's see. What's your name? Owen. I think Owen brought it up about the for loops earlier. So like I said, a loop ultimately is just a jump statement with an if, right? It's comparing, it's seeing if this condition is true or false, and it says if it is, then it keeps going, it gets to the end, then it jumps back up to the beginning of the loop, which here will be line 14, and it asks the question again, true or false. If it's true, it does it again. So there are actually different ways to write loops. So in this case, we could do something like this. We could say for count in, and then this would be, there's different variations Let me see if we pull it up. So the 4. So I'm just going to show you, by the way, where you can go for information. This is a very good place. See, W3 Schools is what I referenced, and they have a very good tutorial, and you can see right here really quickly what you want to look at. Next week, by the way, we'll be doing lists and tuples and sets and dictionaries. We've done if else. Oh, here it is, for and while loops. So if you go to the while loops, you'll see, it's taking a little time. I don't know why. Oh boy. All of you are hitting it at once, right? That's no, it can take a lot of traffic. This site's been around since '99. I've used it extensively. So here we go. While, see, see, and they're using the shortcut operator for increment, and they're using I as their counter. But see, and there's this thing called break, which means you can break out of the loop, like breaking out of jail. Don't do that if you happen to get in for some reason. But it breaks, right? It goes out of the loop. That's what break does. If you want to play around, continue is sort of the opposite of break. And then we're going to go to for loops. So this is where you go to look up the information, and there's different ways to use a for loop. The for loops are very useful for if you want to just count like we are doing, as well as going through collections, which a collection is just a bunch of items. In this case, this is a list. You may think of it as an array. Python doesn't have arrays as such. They're called lists, but they work basically the same way. And you can do something like this, for x in fruits. So we see fruits here is just strings, apple, another string, banana, another string, cherry. And what this will do is it will set x equal to apple, and then the next time it loops around, it'll set it to banana, and the next time it loops around, x will become cherry. So you get this really nice short syntax, but what's going on under the hood is Python's doing a lot of stuff for you, right? Now, the for loop that we're going to use is going to be using range. And this is why also a reason I don't talk about the for loop very much in Python, especially in the beginning, because it's very much unlike any other language. Pretty much all other languages have a very set format for their for loops, and that is, did I go to the right one? Let's see. Oh, it's just right here. Generally, it would be in the format of, and if the and I think you mentioned you're using etc. So it's probably C++ or Java. It would be your counter. So count equals 0. You'd set it, to 0, and then you'd say the condition, which is count less than ducks. It's the same condition as we had before, right? And then another semicolon, but this is not Python, by the way. This is another language. Then it would be what you do with count every time you go around, which it would, in any other language, it would be, a count plus, right? So this encapsulates all of what we did with the while. We just did it with a while manually and did this, ourselves. It makes it a lot simpler if you're doing something with just counting up or going through a list, right? So essentially, the way you do a for loop in Python is you have to use the range function, which essentially is just a way of, let me go back to it and show it to you, range 6. So it goes through, goes to 0 to whatever the range number you put in is minus 1, because it goes through range 6 items, right? And in computers, pretty much all languages start counting with 0. They don't start with 1 like we do. So 0 is one of those that it counts in the 6. So if you put 7, it would actually go from 0 to 6. If you put 10, it would go from 0 to 9. But it still goes the number of times that you put in, right? So in range 6, this is still going to loop 6 times from 0 to 5, right? So let's do that. There's some different variations on range, but we're not gonna do those. So for count in range, and we want to say ducks, right? Because that's the range, right? If we put in 3, we wanted to count 3 ducks, 0, 1, 2. So I'll just put that in a comment. So for 3 ducks, it would be counting 0, then 1, then 2, and then end. Okay. So let's do this. Do this control slash, get that back. And we want to take this away now because we don't need it, right? This is doing this range, and this for loop is doing this for us. Yeah, you can think of it, the for loop does it for us, right? So let's run that and let's see if I'm lying or not. All right, so let's put in, say, 3 again. Enter duck, 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 goose. Hey, look at that. It worked. Now, just to make sure that there's no funny tricks going on, I'm not going to do 3 this time. I'm going to do 5, something I didn't do. It's just I pick a new number. So do 5, duck, 1, 2, duck, 2, duck, 3, duck, 4, duck, 5, and goose. Pretty neat, right? And this is a much shorter way to do it, even though it is slightly more complex to understand what's going on. It shortens how you work with these numbers and with these variables, right? And it takes care of some things for you, so you don't have to type everything out. And next week we'll go over, we'll definitely be using for, because it's a really fast and easy way to get through lists, right? Because you don't want to say counting and then say I want the 0th element, the first element, the second element. You just want it to just go through the list and just end when the list ends. And you don't want to have to think about the conditions if you don't have to. And so that's what a for loop allows you to do. So like I said, in terms of the exercise, so random, I'll show you how to do a random number quickly, and then I'm going to go ahead and probably end the live session, and then I will email out once I find the code. I apologize about that. Sys, that was for another experiment that I did. I was playing around with something. We don't actually need it for what we're going to do. And by the way, so if you want to do all kinds of neat functionality, you can look up the libraries you need to import. You can just Google that kind of stuff. Yeah, you can do that sort of thing. Yeah, coloring code, changing. It's a lot of system functionality, right? Sys is short for system. Okay, so last thing is we want to make a random number, right? So we want to count a random number of ducks. So instead of an input, we're gonna not have user input this time. And then we're going to say we don't actually need this. Let's see. And we still need to have the ducks variable, right? So we need to now use the random number generator to get a number, right? Just a random number. So we can say ducks equals and then random dot, and then you can just go through here, by the way, to see all the different options you get for random. This is the random library. It's a very random library. And lo and behold, there's actually a function called random. That's the one we want. Random, and then open parentheses. And what it does is it gives you a decimal number between 0, if you read that, let me hover over it again to show you, in the interval 0 inclusive to 1 exclusive. So if you know anything about math and range notation, that square bracket means it includes the 0, and the parenthesis on the right of the 1 means it doesn't include the 1. So you'll get anything from 0 to 0.9999999 and on and on. You know, it's as many significant digits as the data type can hold. All right, so if we get this, we don't want that for number of ducks, right? We don't want 0.25 ducks. That doesn't make any sense. But what we do with this is we multiply it by the maximum number we want to get. So say we don't ever want to have more than 10 ducks. So you could say times 10. And essentially, if you get something between 0 and 1, it's going to be a fraction of 10. Right? But we also don't want a fraction. We need an integer. We don't want a real number, because right now ducks is going to be some floating point number. That's what this happens. So if we got 0.99, for instance, it would be times 10 would be 9.9. Well, I don't know about you, but 9.9 ducks is kind of hard to count. That's not going to work so well. So what we can do, the simple way, is just convert it to an integer. Just like we did with the input, right? We're just replacing. See, this is and it's analogous to what we did here with asking the user for input. So instead of getting input from the user, we're getting input from the random number system. By the way, we actually have to seed the random number. There's a thing here. In fact, I think it talks about random numbers in this as well. I'm not sure. It talks about NumPy random. So modules, math, random module. There we go. So you actually have to do what's called seed it, because technically a computer can't do random. You don't want a computer that does random. That doesn't make any sense. You want it to do the same thing over and over if you give it the same input and the same instructions. To make something random, it's actually called pseudo-random, which means fake random. It sort of fakes the randomness. And the way that you can do that is there's actually a chip in the computer that does it for you, but you need to give it some starting value to like you plant seeds in a garden to get fruit. We need to plant a seed, a number, in order to have that give us back some random sequence of numbers. To give it some randomness, we need to apply external randomness to a system that's not random. Right, because a computer, again, you don't want a computer that's random. If you ask it 2 plus 2, it should give you 4 every time, not like say 5 or 10 or negative 100. That's not a good idea, right? So we need to seed it with something outside of itself, like a time, or we give it some mouse movement or whatever, to give it some hint of randomness from the real world. So we need to do that. So we'll say random dot seed, and then we seed, and then we can pass in a value. So I'm just going to say 10 for now. But now if you do the same seed, you're going to get the same random numbers every time. The way to make this different, and I think that's so time dot so time. So we want to get the current time. If you go here to the modules, so we want to find, I'm showing you how you would go about finding, say, what do we want to get the time. But first, I'll show you what happens with the same number. So let's say ducks equals random. First of all, we need to finish this int. So we convert it to an integer. So if it's 9.9, it'll convert it to 9. It just chops off the rest of it. It doesn't round it. That's different from rounding. And then we have count. So let's try it. So run, duck, duck, duck. It's 3, 4, 5, 6. So 5. 1, 2, 3, 4, 5. Let's try it again. 1, 2, 3, 4, 5. Duck. You notice a pattern? Notice a pattern there? Anybody? It's the same, right? And the reason it's the same is because I seeded it with the same random value. Remember, a computer's not random. It's not random at all. So we basically need to have something that changes from time to time as our seed value. So we can do that. I sort of started off to show you that, and I wanted to show you what happens when you don't. So I'm going to change this to seed, and I'm going to say time dot local time. Okay, let's run that. 2, 3, 4, 5, 6, 7, 8. Hey, 7. Let's see. 1, 2, 3, 4, 5, 6, 7. Okay, we got a different one that time. Let's see if it does it again. Let's see. 1, 2, 3, 4, 5, 6, 7. Oh, uh-oh. Is that really random? Did I pick the wrong function? It's possible. Nope. There we go. 1, 2, 3, 4, 5. See, now we're getting some kind of pseudo randomness, because the local time, the current time, is going to be different at every second, right? 1, 2, 3, 4, 5, 6 that time. So I'll share this code as well as when I find it. It's not gone. It's just I've lost the reference to it offhand, and I don't want to waste time on the stream to try to find it again. But this is basically how you make some kind of random function, right, and get a random number. And then you can use that to do all kinds of things, like you count the number of ducks, right, to make it random, so that you even don't know when you're going to say goose, as well as guessing game. which is essentially that's going to be the project for the after, on your own time. And I'll give you both the Elmer Fudd Bugs Bunny game, which is shows you the entire process of random number generation, and then sort of trying to find a certain value, whether or not you find a rabbit, whether or not you catch it, and then on your own I'll give you the instructions and the basic template for a guessing game. Any questions? Does that make sense, more or less, how this works? The random, mostly the loop. I mean, the loops are that was the concentration of today. Um, and you can see how this is very useful, right? A computer is very useful when it can do things over and over and over again, because, if you're a normal human like I am, just doing the same thing over and over any more than 3 or 4 times, it gets pretty boring, right? You don't want to do it anymore and you get tired. So computers are great for that, and you should definitely use them for that kind of purpose. All right. So if there aren't any questions, then I'm gonna go ahead and go ahead and finish the recording.